Okay, today guys, we're getting ready to film the second video here, and we're going to continue with lesson 6-9. This will be the second part of it. The I can statement for this problem is I can write and solve an algebraic equation for a real-life problem using inverse operations. And inverse operations, that traditional way to kind of solve, is what we've been focusing on this lesson. So we're going to kind of put it all together here and do a full problem with every part of it using our algebra we've learned. Okay, so the problem, this is kind of a big one. There's 4 parts to it, and it's going to combine a lot of stuff we've used in our algebra units so far. But the problem is Ethan and his brother each sold the same number of raffle tickets. They began with 42 tickets in all. After the sale was over, they were left with 8 tickets in all. How many tickets did each brother sell? Okay, so the questions that we're going to have to answer, there's 4 of them. In this process. First of all, we need to define a variable and what's missing. We're going to represent this whole situation with an equation, which we've done in a past unit. And this is sometimes a tough step to try to get the situation into an algebraic equation. Then, of course, we'll solve using our inverse operations. And then we'll plug in our answers and substitute to check to make sure it's correct. Okay? So for the variable here, we're trying to figure out what we don't know and what we need to find. So we kind of need to look at the question here, and it said, how many tickets did each brother sell? So the tickets are what we're trying to find. So I'm going to call T for tickets. And so I will just define this by saying T equals, okay, the number of raffle tickets. And we'll just put tickets here, but number of tickets sold by each brother. Running out of room here. Okay, so that's what we know we need to find, the number of tickets sold by each brother. Okay, so now comes the part where we have to do our thinking and try and get this put into an algebraic equation. Okay, so in this situation we find out it's Ethan and his brother. So there's 2 of them selling these raffle tickets. Okay, they have 42 of them that they began with, but when they got done, they still had 8 left. So our goal is to find out how much did each brother sell. Okay, and we know the T stands for the tickets sold by each brother, or in this case, one brother would be T, but there are 2 of them because they each sold the same amount. So an equation we could write to represent this situation is, we know we have T as the number of tickets that each brother sold, or just one brother in this case. So we could put T, and then I need to take it times 2 because there are 2 of them, because it says that they started and they sold the same number of tickets. So we know with multiplication we can just put 2 times T, and we'll use a small t here. I should have used a small t. So 2 times T, the number of tickets, and we got to double it because there's 2 brothers. And we knew that we had 8 left. So if we add those 8 on to what they each sold, we should total that 42 tickets that we started with. So again, this is the part that a lot of kids struggle with, because they have to put all of this in the word problem and understand it and get it into an algebraic equation. So in this case, each brother sells T tickets, and I got to double it because there's 2 of them. Add the 8 that they didn't sell to get me a total of 42. And here in a second, I'll show you there are other ways to think about this, but this is actually the situation to get to that total of 42 tickets. Okay, so in our last video, we talked about how to solve using inverse operations, which we're going to do here. Okay, so I'm going to rewrite, and I'm actually going to use this other marker here that works a little bit better. All right, so let's write our equation and talk about undoing things. 2t plus 8 equals 42. And we talked about in the last video that we keep the 2 times the t. We're going to take care of that last. But if I add 8 to one side to undo that, I subtract 8. So I'm just going to do it up here. And that's an inverse operation. It undoes it like it never happened. If I add 8 and then subtract 8, it becomes 0. There's nothing there. So really, you could look at this and say it's 2t plus 0, which is just 2t. This I can cross out because it's nothing now. They undid each other. Now remember, to keep it equal, like our pan balance, when our example, we want them to stay the same. What you do to one side, you got to do to the other if you're thinking weight-wise, like a pan balance. So if I take 8 away from this side to keep it balanced, I also need to take away 8 away from this side. So if I take 42 minus 8, I'm left with 34. Okay, so the part of the equation I have left, this is a two-step equation, and this is as hard of a problem as we'll have. We won't do anything more complex than this year. But this says 2 times t equals 34. So how do I get t by itself? Our goal is to isolate that variable. Well, if I took t and took it times 2 to undo that, so like it never happened, I can divide it by 2. So if I divide by 2 here, you can say that cancels each other out, and we're just left with t. Because I multiplied it by 2, then I divided it by 2, so it's like it never happened with those inverse operations. So again, to keep it equal weight, if we're thinking pan balance, I must also divide this side by 2. So 34 divided by 2, and I'll slip over here and write the answer. On this side, I'm left with t equals, and 34 divided by 2 is 17. So if I go up and look now, my answer is t equals 17. So the number of tickets each brother sold would be 17. Now I want to double check that to make sure I'm right. And to do that, we substitute and plug it back into the equation. So if I go to my original situation and plug in, t is the number of tickets each brother sold, and I'll plug in a 17. I'm going to put it in parentheses here. Put the 2 out here, so that becomes 2 times 17, which we know is 34. So 34 plus 8 is 42, and then I've proven my answer is correct. Okay, so we know each boy sold 17 of those raffle tickets. And assuming that we wrote our equation correct, which we did when we substituted in, if it works, we know we're correct. Okay, so there are other ways to solve this besides this. I know a lot of you might do some inverse operational thinking. For example, we wanted you to write an equation, but some of you might think, well, I mean, you can use your logic. If they started with 42 and they didn't sell 8 tickets, you could think, well, just subtract those 8 tickets right away. So maybe if you're thinking up here, I have 42, and I take away those 8 tickets I didn't sell, I'd be left with 34 tickets they sold. And then you could think to yourself, well, the 2 brothers sold the same amount, so I could just divide that by 2. So really, the thinking is just the same, but we really want you to get it into this equation. And when we hear equation, we have to have that equal sign, and we want you to have a variable. In this case, it's t. And when you're kind of doing it this way, you don't necessarily have that situation. It's a 2-step problem. So this is a little more complex. Not saying there's anything wrong with that, but you're using your logic and your common sense and your understanding of inverse operations to solve. But try to get it to this an equation, and then we can solve by undoing things using those inverse operations, okay? On your exit slip, guys, you will have one problem like this where you'll kind of be asked to what's the variable and go through these steps a little bit. So do the best you can. This is the type of problem you're going to do in real life where you have to come up and get the situation yourself and then solve it. I know we're focusing on the solving with inverse operations, but this kind of puts it all together for us. So again, do your best on the worksheet with these inverse operation samples that you're going to have to practice, and then give that exit slip a whirl and see how you do. We'll talk to you guys later.